Showing all the details for how to plot an ellipse is not a quick thing, so by all means, skip through sections of this video if you know how to do those parts. Step number 1, this is what I'm going to start with. I want the standard equation for my ellipse. So what I like to do is get all my x values on the left. This is going to be 36x squared minus 288x. And then all my y values on the right-hand side, not of the equation, just next to the x's. So 9y squared minus 18y. And then let's bring that 261 over to the right side, because I know I'm going to need that over there eventually. The form I'm going for, well, we'll get to that in a moment. So GCFs first. Pull out the 36. That leaves you with x squared minus, is it 8? I think it's x squared minus 8x. There we go. And then we pull out a 9 as the GCF from the y's. So that leaves us with y squared minus 2y. We still have our negative 261 over here. And now's the first hurdle. I have to complete the square for each of these groups of x's and y's. And what I would like to do is point you to where I'm probably going with these. X squared minus 8x, that's going to be some kind of an x minus 4 squared. Okay? And this one over here, y squared minus 2y, that's going to be some kind of a y minus 1. Now, how to get there? Well, we have to add some numbers to make this work. 36x squared minus 8x. And you can imagine foiling this backwards. What's negative 4 squared? Well, that's going to be plus 16. So I'm going to have a plus 16 in here. And if you're adding that to the left side of the equation, you have to add that to the right side of the equation. So look at the right side. This is turning into negative 261. And then it's going to be plus 16 times 36. Don't forget about that GCF. Okay, next part. The y's. This is 9 y squared minus 2y. And if you FOIL this out, you'll see we're going to get a plus 1 right there. So let me add that in. Plus 1. And if I add it to the left side, have to add it to the right side. So that's 1 times the GCF of 9. Now, if you add these up on the right side of the equation, all these numbers over here, negative 261. Well, let's do this out. Yeah, okay. That's going to be, what do we got here? 324. So now you need to just divide everything by the right side number, 324. 324 and 324. So we cross some stuff out. This is going to work out nicely. And you get the following. X minus 4 squared. 36 over 324 simplifies to 9. And 9 over 324, well, that's easy. That simplifies to 1 over 36. And then, obviously, 324 over 324 is just 1. This is what we have. This right here is our standard form. Okay? Now, we learn a couple of things from this. There's a lot of reasons we like this form in particular right here. And I want to write the first and most obvious right below it. Notice that the y number, which we call b, is greater than the x number, which we call a. Okay? Now, when b is greater than a, that means it is a vertical ellipse. You see, that's why I chose the vertical ellipse diagram for this particular problem. The standard form equation, we already talked about that. That's this guy. The center is located according to those h values and the k values that you see inside the standard form. And remember, these are flipped because we're talking about shifts. So that's going to be x equals 4 and y equals 1. The vertices, according to this diagram, when you're dealing with a vertical ellipse, which is what we have, you go straight up and down from the center. Now, in the diagram, it's centered at 0, 0. Life's not so good for us. Ours is a little off-center. So you have to start at the center, given right here, and shift up and down from that. So it's going to be 4, not 1. How much is it going up? Well, it's going up by this distance, b. Okay, what's b? Well, if b squared is 36, that means b is 6. Okay, so we're going to be going up and down by 6 from the center of this ellipse. So that gives us, let's see, 4, 7. and 4 comma negative 5 for our vertices. Co-vertices, what are these guys? Well, look over here. The co-vertices are the other ends of the ellipse, the shorter ones, which run along the minor axis. The minor axis is the diameter of the ellipse that goes down the short side. Okay, if you hear the word minor axis, that's what it's referring to. Semi-minor axis would just be half of that. Anyway, the co-vertices are located at a distance a from the center, left and right. Now, since a squared is equal to 9, that means a equals 3. So we're going 3 to the left, 3 to the right from the center. So what does that turn into? Well, 3 to the left gives us 1 comma 1. 3 to the right gives us 7 comma 1. Okay? So we've located all the vertices and co-vertices and the center. This is great progress. We just need to move on to the foci. The foci are, kind of funny word. Have I used blue? Yeah, I've used blue. Let's try green. This thing right here. It's kind of what you can imagine if this were a planetary orbit. It's what the planet would be orbiting around. This is kind of the mathematical center of gravity, not the real center of gravity. But you see, the farther these foci swing out towards the edge, the more tight this ellipse is going to be. So I just drew a very tight ellipse as an example. That's not the case here. This is a pretty healthy looking ellipse. And the foci is going to be located at a distance c. Okay, now here's the part that people sometimes get confused about. The way you find c is by the following equation. C squared equals the absolute value of a squared minus b squared. And that's a very useful equation because if you're dealing with a vertical ellipse versus a horizontal ellipse, well, either a squared is bigger or b squared is bigger. And this equation covers both cases. So for us, that says that c squared equals the absolute value of 9 minus 36. Of course, you could have said 36 minus 9, that's fine, which means 27. So c squared is equal to 27, meaning c is, let's reduce this one, let's say 3 square root of 3. Okay, that's my c value. It's how far from the center we go to reach the focus. It's that distance right there. So we would go up and down because this is vertical from the center. Remember, we always start at the center. So this is going to be 4 comma 1 plus 3 radical 3. And the other one's going to be 4 comma 1 minus 3 radical 3, right? Straight up and down from it. And the last idea that I want to talk about, the major idea here, is what's called the eccentricity. Now, eccentricity is a measure of how elliptical your ellipse is. I'll draw you a very non-elliptical ellipse. Okay, pretty good. That's a circle. The focus is at the center, and you can see it doesn't look like an ellipse at all. It's just a circle. But a really extreme ellipse, here's one, is one where the foci are so close to the vertices that they're almost right on top of them. That's a super elliptical eclipse. And what we want to do is we've defined this word eccentricity to describe how elliptical the ellipse is. And here's the definition. Eccentricity E equals, I'll call it the focal distance. I hate to overlap with parabolas, but what I'm trying to say is how far from the center you get to the focus. Okay, I need this to go away. It's the focal distance divided by the semi-major axis. The distance of the semi-major axis. So in the case of a circle, that would be what? The focal distance is 0. It's right on the center. And the semi-major axis, I don't know, is anything. It could just be A, but that's going to be 0. So the eccentricity of a circle is 0. Whereas in this case right here, notice that the focal distance, that distance, is almost the same as the semi-major axis distance. So in this case, something very, very elliptical, this would be almost equal to 1. Well, let's figure out what it is for us. The distance to the focus in this example was 3 radical 3. Okay, and the semi-major axis distance, right, from the center to the vertex, remember what that was? That was this value right here, 6. So that's all eccentricity is. It's a measure of how eccentric this thing looks. So now the easy part is we just pop everything on a graph. Okay, and if we've done all the work already, this part's pretty easy. I'm going to put the center on here I know it doesn't ask you to plot the center as a point, but I'm going to put this on here just so I can keep myself oriented, and then we'll take that away. So first I'm going to draw the semi-major axis, and remember what that is. That goes, where did that go? The vertices, yeah. So I'm going to draw the vertices, which go from 4, 7 to 4, -5. So it's an axis that looks like this. 4, 7 up there, and 4, -5 over here. I don't need the center anymore. And my minor axis goes from 1, 1 to 7, 1. Okay, and I'll just stick some dots there so we can see our co-vertices sideways and our vertices vertically. And let's see, so I did the vertices and the co-vertices, we got that. Segments of the major and minor axes, got that. That's the lines. And what's left? The ellipse. So easy peasy. It's easier to draw with the tool, but this is approximately what you're going to get for this shape. Okay, nice vertical ellipse.